Okay, hello everyone. I'm actually going to present in English because that's how I usually do this talk and do my talks. So that's going to be the language of the presentation. I just pasted the materials, the resources for the presentation on the Discord. So if you want to get the slides or the code or just one link that I'm sharing with you that's useful for further learning, please go there. I also shared a little newsletter that I sent to people from conferences, which includes like recordings of my future and previous talks. So if you like the presentation today, you can sign up and I will send you some stuff. But I'm doing this pretty rarely, but if I'm going to talk at the conferences more, I'm going to send you more materials. So just to tell you what the presentation is going to be about, it's going to be mostly about the process of developing with AWS Lambda and API Gateway. We're not going to go much in depth into implementation or using the database or doing CRUD endpoints because this is the common knowledge. What I'm going to focus on here is on how you can streamline your development process and how things other than code work, because that's what's usually omitted from the tutorials and from introductions. So I'm going to give you kind of a framework of how to work with AWS Lambda using serverless framework. So no bullshit, no opinionated approach. I'm going to show you how to set the projects up, what the Lambda is about, but without going into that much detail for the introduction, and some tooling. So I'm going to show you how to use a very basic CI pipeline to deploy your AWS Lambda code on the fly right after you commit on your GitLab repository. And then I'm going to also mention how to do testing, how to avoid vendor lock-in, and all sorts of useful stuff. We're probably going to have some time for questions, so please ask them on Discord. A little bit just about my background to give you an idea. I work at the company called Artigen. We do coding and data analysis based on genetics, based on DNA and patient data, and we basically help scientists find better drugs, mostly those focused on cancer. So hit me up if you're interested. Also, I contribute to some open source things and working on some of my own ideas. So if you want to collaborate in any way, just let me know. I also do some consulting, etc. So for the plan, we're going to do basic serverless concepts, discuss of what we're going to build, then set things up manually so you see like how those things work in the AWS ecosystem. Then we're going to start working with serverless framework, then some coding, then CI setup, and I'm going to leave you with some resources and we can wrap up with the Q&A. So just a quick refresh on serverless computing. This is a buzzword, but if some of you weren't coding using serverless approach so far, just quickly, serverless computing is a method of of deploying and writing services that focus on as used basis. So you do not manage servers, you just write and deploy code. The infrastructure is provided by a cloud provider like an AWS. So there is pretty much no boilerplate, and the endpoints and APIs are very plain functions, and the cloud providers basically give you what a team or your classic virtual machines gave you, plus the framework in which you write the code. And as you will see, the code for servicing things for writing API is really simple because everything else is provided by the cloud provider. And AWS Lambda is something we call function as a service, which is a serverless way to execute some code. So you are able to write and update the code on the fly, and then this code can be deployed and it can execute in the response of an event. So an event would be an API call that you usually do from your front end, but it actually can be other stuff. So any automation. let's say you have an application that uploads a file to a storage, for example, to AWS S3. So you can ask Lambda to be triggered when the new file appears, and for example, transcode this image to smaller sizes to use on the website or to run some other processing. I actually, as for like the real world use cases, the main benefits of those serverless and function as a service approaches are in many cases the cost. So for example, the function as a service, the service infrastructure API basically doesn't cost anything if you don't use it. It's pay per use model. So you pay for single runs, not for maintaining the server in the long term. So if you have an application that's really, really small and is not used that often, that's great. But also this pay-per-use model works in a way that it's scalable by design. So you can really handle a lot of requests and you do not worry about adding another servers. The cloud provider does that for you. So they duplicate your code on their infrastructure and it's just runnable. One thing that I really like about coding in Lambdas is the speed of development. Basically, you are able to develop really, really fast without the boilerplate, without, planning really project setup in the project. You just write the code and the API is there. So for quick prototyping and actually for development velocity, this is really useful. It kind of requires having an open head from the client, so they are not scared of cloud technologies. But if you kind of write the plan for the project and you say that we're going to have more time to develop the product better, this usually works. And I'm also going to talk about some more benefits later on. So as for what we're going to build, this is going to be just a basic REST API. You can build upon those endpoints, and we're also going to configure development process. So let's start with AWS Lambda manual setup, just so you get an idea how that works. I'm actually not going to do live coding. I'm going to show you those things on slides because, well, it's entertaining for me, but probably for you, it's better to look at the results and how that works. So if you have the presentation, that's the link where you have to go in AWS. What I'm not showing here is setting up AWS account and setting up AWS CLI. This is described over and over everywhere. So I leave that to you. So we go to an AWS console and we choose AWS Lambda. And then if you don't have any Lambdas, then you just click create function. It's also an orange button, so the red box probably is not needed. Then we want to see an example. So you can offer from scratch, but we're actually going to use the blueprint. And one thing that I want to underline here, this is not the way to write serverless functions. It's a way to prototype them, to play around. But what I'm going to show you in a second is an automated way how to develop those apps. Because this is easy and it's GUI, but it cannot work in the long term. You cannot, as you can see, you can version control, etc. So we use a blueprint, and there are some examples. If you search for "Hello World," you can get "Hello World" with Node.js. So let's do that. Let's configure. The next step, if you're not familiar with AWS, might be weird. So function name is easy. It's the way you identify your function. But right below that, you have an execution role. So basically, AWS Lambda and every AWS service in general needs permissions to some resources in order to operate. So Lambda has its own permissions that are needed. So here we create a new role with basic permissions. But you can actually use an existing role or later on change this role that you create here in order to give it more permissions. So we're not going to do that here, but if you use any database in AWS, like RDS or DynamoDB, or you use some authentication, use S3, you want to use any other services from AWS, you need to add permissions to the Lambda. But this way, you do not have to exchange any keys and hard code them in the code. You just have to have an appropriate role in here, but it's still a manual setup, which we're going to take care of later. And actually, if you scroll down further, we can see a sample code of Lambda, and your endpoints won't look much different. So there is a handler that if you work with Node.js, you might be familiar with exports. If you work with front end, you probably use ES6 modules, or in React, not really. But we have handler, and one thing is that the code before function also executes, and we have a handler. So one thing that's done here, and it's commented out, that's how they show things, is you can, okay, so actually the Lambda function gets two things, event and context. And this is an asynchronous function, at least can be and should be. And you receive an event and context. And this is what tells you like params of the request and parameters for the URL, which I'm going to show you in the second. So you can log this event if you want to play around, but also we have some console logs with the values from the event, and returning from the function is doing a simple return statement. So that's it. If you for the things you need to know about actual Lambda framework. When we go to create function, we can see this screen. And as you can see in the middle, there is a basic function. This is a visual representation of our Lambda. And on the left, we have add a trigger button, and on the right, add destination button. So I mentioned that Lambdas can react to events, like adding a file somewhere, or HTTP request, like an API, or going to a URL. So this is a trigger. Trigger is the thing that runs your function. Also, there's a destination, and so your Lambdas can work in different ways. You can, for example, have a request as a trigger, and destination would be creating some file, or if you want to make a Lambda that uploads files somewhere. So this is a visual representation of that, and this interface is focused on visual work on Lambdas. If you actually, in this view, if you scroll down further, you can see a simple IDE, and you can actually edit Lambda code on the web on AWS console, which is recommended probably only for prototyping, but you can edit the code here and play around with that. That's one thing. If you scroll further, actually, in the interface, you can see more options. I'm not going to go in depth here, but you can, for example, configure things with environment variables, have other settings, how long the Lambda should execute, how much resources should be assigned, but we're not going to need that here. So let's actually see how the Lambda works, and we can do that by testing. So you can test Lambda online on the AWS console. So if we click the test button, for the first test, we're going to get a pop-up to configure test event. So we're going to create a new test event. The event template would be hello world. That's one of their test events, and actually it fits our code. And the event name, we're going to call it test1, and the JSON one is from the template. So now if we click OK and then click test, we should get a result, a pop-up with a result. And basically our Lambda executed, it returned the value 1 as was there in code, and returned some logs. And these are logs that are available for you in AWS CloudWatch later on, and everything you actually print in the function is going to be logged. One thing about it here is you can see several things here. For example, duration. It took 4 milliseconds, and build duration was 100 milliseconds because that's the minimum time they bill. And the RAM that was used was 128 megabytes. That's just some information here. If you have more heavy Lambdas, you might want to assign more resources. One thing that to note, just I'm going to take a look back at the code. So what we saw there, the return event key 1, that's why we get the value we got, because in the test event we have configured key 1 to be value 1. So Lambda, you know, it's a simple matter of having an input and having an output, really. So okay, that was just Lambda working, but how to actually have it be accessible via a URL. So that's why we use API Gateway, and that's what I'm going to show you today, also graphically, pretty quickly. So what you can do is you can add a trigger. As I mentioned, these are triggers for the Lambda function, and these can be different, but we're going to use an approach of creating a REST API. So when we click that button, we get a trigger configuration. And as you can see on the top, we choose API Gateway. If you do it yourself, you can actually choose different triggers and play around. We don't have an API Gateway configured, so we're going to create one and specify REST API as this one. And as for security, we're going to use open. There are different solutions here. For example, the great thing you can do is to use cognito authorization, which is if you use OAuth or any other external provider, you can use it here. Also, OAuth is supported. And basically, that gives you an out-of-the-box user authentication. So if you need to create an app with authentication, which most of us usually do, you can pretty much use something out of the box here also for endpoints. So when we add that, the trigger was configured. You can see that we have on the left an API gateway as a trigger, and on the bottom you should see a URL of your API. But actually, if I go to the API now, we will get internal server error, and that's because we have to configure some more stuff, but only a little. Really change the form of the response. So going back to Lambda interface, if you want to debug and see logs why things failed, you have a monitoring tab, and there are logs for all executions of your Lambda, so you can see what was wrong. The thing we need to change is actually to just change the form of the returned response, because well, as you can see, Lambdas are very simple functions, but to actually provide some features for HTTP requests, we need some information. So here you can see that the correct Lambda would return an object with a status code. You can specify whatever you want. Here we have a proper response, so it's 200, and the body is just status OK. So you know, not much here, but that's what you need. And if you go to actually to the API Gateway control panel, that's what you see. You have a /basic function endpoint there, and you can add other endpoints and assign other Lambdas. And if you need to quickly say prototype an API, you can do it here. Also in this panel, you can get Swagger or Open API definition. If you coded an API, you probably know what that is. You can generate really cool API documentation files from that. So it's all available here. Okay, so we did things manually, and the thing about this, as you probably saw, is that everything is done in the GUI. So that's not ideal. When you code, you want to collaborate with people. And you want to have different environments. So there is no way to version control those Lambdas. So if you delete one, you cannot restore one. Also, you can make an error and break production environment. And if you want a staging environment or development environment, you can't, because you would have to create all the Lambdas and API gateway again, and then assign permissions, do all the stuff over and over again. And migrating between AWS accounts would be painful. And one of the solutions that is there, and the most popular one, is to use Serverless framework, which provides many tools for Lambda and serverless development, and not only for AWS. So if you want to like visually orient yourself, this is the logo, and you can go to serverless.com to find out more. So why use serverless framework? This is the great question. I'm going to quote a database here. It pretty much gives you anything to develop, deploy, and monitor and secure services, serverless applications on any cloud, pretty much. So the develop, deploy, and secure are built in. The monitor is something they sell. They sell you a monitoring backend for your AWS Lambda, which works pretty nice, but you don't have to use it. They open source the framework, but they actually make some money on the services. As for details, what is supported? If your company or yourself don't like AWS, the knowledge from today is going to be useful as well, because serverless framework supports AWS, Azure, GCP, and other cloud providers. For example, even if you want, sometimes clients want us to deploy things internally with no cloud because of security, etc., etc. You can deploy that with a properly configured Kubernetes via a kubeless tool. So what changes is the way you use the resources like databases, but most of the code is pretty much transferable. It's similar. So migrating between cloud providers is possible. I'm not saying it's always easy, but there is this possibility, and that's pretty nice. So serverless framework is used by all those providers. And also, what is funny is for the AWS, they have their own framework they call SAM, but it's much more cumbersome. And even in official AWS documentation, sometimes there is a description how to do things with serverless framework, but not with their own framework. So as you can see, it's really, really good, and takes care of a lot of things. Basically, if you worked with AWS, specifying infrastructure there via CloudFormation files, which are JSON or YAML, is really cumbersome, and you get those things pretty easily here. For languages, we're talking about JavaScript, namely Node.js here today. But if you are programming in different languages, you also have Ruby, Python, Go, Java, C#, actually F#, and custom Lambda layer runtimes, which are supported. So right now, AWS also experimentally supports C++ and the Rust. There's probably no point, but if you have a code base in that and backend developers in that, you probably can work with that. And also custom Lambda layers. So if any of you is a Bash magician, there is a Lambda layer for Bash, and you could use that with serverless framework as well. For the main features is the ease of deployment. The local testing is possible, so you don't have to run it in the cloud. Actually, you could work on your Lambdas on the train or in a remote location and not worry about your connection, like I'm worrying here. So that's really beneficial. There are plugins, community plugins, so you can create resources on AWS using plugins or write your own CloudFormation code, and it's integrated really, really easy. The question that always is asked about Lambda is pricing, so I'm going to quickly tell you about that. You get quite a lot in the free tier, and for small apps, you probably won't pay anything. So for the number of requests, you get free 1 million requests for your API, and then you pay 20 cents per million requests. That's just requests. And then you also pay for the compute resources used. So the free tier gives you 400,000 gigabyte seconds, and gigabyte second means basically how much RAM time you used. So basically we used there 128 megabytes. So for 400,000 gigabyte second, that gives you a pretty good margin there for over the million requests. One thing is that the CPU in the Lambdas is relative to the RAM. So if you need more CPU, you have to increase the RAM, and that's how the CPU CPU is increased. But as you can see, you can get started for free, and that's always free. That's not like for a year or for a month. That's free always, and also only if you surpass that you pay. You can get quite overboard with that, so it's important to set things up to have timeouts, so you don't have like continuous loop running all the time, or some rate limiting setup. But I think the pricing is fair here. It will be cheaper for a really large application to maintain a server, but the ease of use and the speed of development, for me, they are unbeatable. So for the setup, you need npm. We are on the JavaScript talk, so you have that, and you install serverless tool. And to set up a project, you have to run serverless command. So right now we're going to switch more to actual code and the console here. So if you type in serverless, you can create a new project. And then you choose what language you use. We use AWS Node.js. Then we call the project. I call it JS API. And then serverless asks you to probably use their monitoring. We use no, but if you use that in production environment, that it might be useful to consider that. So what gets generated is really not that much files. These are 3 files: getignore, handler, and serverless YML. Serverless YML has a lot of comments, so you have examples there of how your config might look like, some additional options, but this is everything that's not commented out. So we have the name of our service. It is important because, well, serverless is stateless, and you do not have to have any local keys stored to redeploy stuff. You just need a name, basic name, and then in the context of one AWS account, you can redeploy things between computers, CI environments, etc. So then we specify a provider and runtime. As I said, there are multiple providers like AWS, Google Cloud, Azure, whatever you want, and runtime is Node.js. Right now, it generates 10.x by default. As you can see, Lambda suggests 12.1. These were not a major upgrades, so we can continue with that. And then with functions, specifying a function in our application, you give a key that is name, which now is hello, and the handler, which is handler.hello, which references the function in the handler.js file, which I'm going to show you in a second. So those 9 lines take care of all of the clicking we did in AWS, apart from actually one single thing. So then we go to handler.js to see how that code looks like. It's really similar to what we saw in a panel in the console. So one thing is that we have a hello function that is a asynchronous function, and we receive event. We can also get context, but event is what we usually need. And the return is the same thing we saw in Lambda, which we return status code, and then also we return some body with a response. Here is a simple response with a text and also an event. We log event so you can see what's in the event. That's useful at the beginning. And then these are just stringify parameters like null and two spaces, but that's just for formatting. So as you can see, making an API is basically making a JavaScript function, which is really cool. You don't need to know a lot really about frameworks. The one thing we need to change in the serverless.yml is add an event that triggers our function. So one change you can see here is that for hello function, below the handler, we added an event section, and we want to respond to HTTP on the path /hello, what you will see in the background, and then the method that we want to use is get. You can do any, allow both post, get, and any other, or just post, or whatever really. And the syntax of the function doesn't change you just process the event variable differently, look for different keys there. So to deploy the function to AWS, when you have AWS CLI configured, you just do SLS deploy or serverless deploy. SLS is the shortcut for that. Yeah, it's faster to type, right? So when you start the process, basically you can see what's going on, and that might give you an idea what's going on under the hood. You can use verbose option if you want to see more, but basically they package the service, they exclude development dependencies that you have in your package.json. The stack is created. The stack is the CloudFormation stack, which is the configuration that gets uploaded. Then it's uploaded to AWS, and the code is zipped and uploaded to AWS to be deployed, and the service gets successfully deployed then, and you get a URL for your function. So you can actually get this URL and paste it in your browser and access your API now, which is pretty painless. Actually, if you go, you can see the message, our what we logged, and actually you can see the input, which is the event, which is useful for learning what's in the event if you don't want to just dig through the documentation. One benefit, great benefit of serverless framework is actually a local testing possibility. So you can see in the first line there is a command serverless invoke local, and then you give it a function name, which is in our case is hello, and we get the same response, but input is empty because we did not have any event. One thing is you can use that to test, and you can also pass a path to a JSON file containing an event. So you can test it pretty much locally. This is not a full replication of AWS Lambda environment, the local one, but it's pretty close. So there are things that don't work and that you need to emulate, but you can determine that with, say, environment variables. You'll pretty quickly get the hang of that. But the sheer possibility of that, of running locally, is really great. If you do not use, if you just do serverless invoke without local, you will go through the process of deploying if it's not deployed, and then running the function on AWS. So you can also test this way without using CURL or the browser. One thing I want to add also, just to give you some more code, but this is not the focus. We also want to show the CI. I'm going to add another handler. Starting from line 14, you can see the hello detail. And I also created a file, hello detail.hello. And the event is different in a way that we add a path parameter. So you can see hello/ID in the curly braces. And we do that with get method. And for the request, we specify what is the path parameter, it's ID. And we say that it's there. You can actually specify more things, like some basic type of the parameter, so it gets validated, but we just get the parameter here. And if we go to the browser, if you go to the input event, you can actually see that there is /hello/ some ID that I typed in randomly, and we get that in the path parameters at the bottom, there's ID. And above that, you can see that there are multi-value query string parameters, the array values, query string parameters, and some headers. So you can access everything about the request in your function. So that's pretty much the basics of the serverless framework. I'm sure you can see the possibilities for you there for your different use cases. But I'm going to focus about a few more concepts, so you have a full development suite for your use. One thing is using the core library. So this is pretty obvious, but if you are used to frameworks, you might feel a little bit lost without a predefined structure available for you of how to structure your code. And the core library really is an answer to vendor lock-in to some degree. So you wrap your business logic that's not AWS or cloud dependent in the core library. You use AWS services via interfaces. So if you use a storage or database, you have some class that wraps around that, so you can plug in and replace this class with something else. And also, the thing is that this is a good development practice, right? Separating your concerns, separating the way you do stuff. So the simplest way to do it, it's automatically imported. Just create a core folder and index.js function, and then import it in your lambdas. And this way you can work with code. I'm just showing that it's possible to import code between files. That's probably a good approach, and it avoids you the vendor lock-in. So you might be worried that you want to migrate from AWS in the future. If you have a core library, it's easy. You can switch to different framework like Express, or you can pretty much just use different provider and just change the handler definitions a little bit. One thing is the most important reason I'm mentioning vendor lock-in is clients. So they're going to probably ask you like, okay, so what if I want to migrate, or what if I want to have it locally, not in the cloud? These are questions that have to be asked. People usually don't migrate, and there's really no need in most of the cases. So you can actually have that possibility there. Migrating is not what is done usually, but it's possible, and it's good to think about those things if you're planning a larger project that, or even any project that you put your effort in. As you can see on the bottom, I just created a simple function that returns a string, and we're going to use that library in our handler. So here we just require the core library, and then use a get result function from in the message in the returned body. So just showing you some pattern here. Okay, so if we test that locally, we invoke locally, we get a result of the function. That's it. So one thing that I want to touch on, but not expand fully, is testing. The way you test those lambdas, especially like if you use them locally, you can use anything you use for unit tests in your front ends, so like Jest, Karma, and test it like any other JS library, especially the core library functions. But even even those handlers that you use, you can test because they are simple AWS functions. You can switch or monkey patch dependencies that require some online services for unit testing, but that's component testing or integration testing. But unit testing here is easy. You can also test, but by invoking locally, and use anything you use for testing APIs, which is like your Postman definitions or whatever else. So just letting you know how could that work. And the next thing I'm going to talk about is continuous integration, continuous deployment. We're going to skip the testing phase here, but I'm going to show you how to deploy your API via GitLab CI. But the same things I'm going to show you work in GitLab Actions. The YAML syntax is only a little bit different, or in Travis looks really similar, or I don't know how that looks for Bitbucket pipelines, but I guess it's similar. So let's see how would that work. We're going to use a CI to deploy two branches, master and develop. So the development and say production or release candidate version is always deployed. So let's see the config. This is the GitLab CI config. It's also not that complicated. First, at the top, we specify stages. And for that, we only have a deploy API stage. You should have a testing stage that will break the pipeline if tests break here, especially if you're doing continuous deployment without approval or on production branches. Then the image we use as a base is node 12. That's just for serverless framework, not for our lambdas, but you can use whatever version. This is a Docker image tag, so it can be another image, but for serverless, we use NPM, so we want a node container that has NPM. We have a deployed task That's a part of deploy API stage. Then we have before script, and what it does, it just is used to deploy our dependencies. In this case, serverless framework, we install it, and then deploying is as simple as I showed you before. It's using serverless deploy. You specify a stage, and I did verbose, so we have logs. We need to configure some variables, but I'm going to show that on the next slide. So one thing, the stage thing, just to tell you what is it about. If you deploy just using serverless deploy command, the stage it is deployed is dev. So I'm going to come back to actually to the browser or to the URL we had somewhere. As you can see in the URL here, just before hello, there's dev. That's the name of our stage, and we can deploy infinite number of stages, replications of our environment. So coming back to the CD setup, we have the GitLab CI variable called CI commit ref name. This is a branch name. So by default, we do master. That's what I used for local testing of this command. But really, you just take master or develop here, because we allow to run this pipeline only on master and develop at the bottom. And as I said, there is one thing you need to configure, which is repository settings. And if you go to GitLab, you can go to CI/CD, and there are variables there. One thing that I'm thinking, you might not have access to GitLab repository that I exposed. So that's one reminder. I'm going to make it available in a second. But one thing here is that you have to add your AWS keys as a variables, and these variables are picked up by serverless framework. So that's your setup. If you run it first, you should get a pop-up at the top of your repository that the pipeline is working, and it should pass and deploy to your AWS account using credentials you provided. One thing, how to get credentials, you get them in your account settings, and you should give these credentials only to deploy AWS Lambda. You can see what permissions are needed in serverless framework, or you can give some more permissions, but please beware with that, because those things happen automatically and you don't want to break stuff, right? So that's pretty much it from me. That's the process I wanted to share with you. It is the way I usually work with Lambdas. The topic is, of course, like more complicated, because you need to access databases, other resources. But these are the things I kind of was looking for when I was working with the Lambda. So these are the things that I didn't know how to do, and actually I would love to have this information available for me. It wasn't, but now I create a presentation with this information. Then I leave you with some resources. And as I said, I'm going to open the repository in a second. And I guess if there are any questions, I'm going to answer those.